So object methods. Not a lot of slides, but the information is pretty dense. So I'm happy to take my time with the lecture for today, just to make sure that everyone is on the same page with it. Okay, so what is a method? A method is here we define it as actions you can perform on a value. You might hear people say things like methods and functions interchangeably. But for now, you can think of just methods as functions. The only reason why we will call something a method as opposed to a function is actually because methods are functions that are tied to objects. So I'll say it one more time. If you have an object and one of the key value pairs, if one of the values, so to speak, in an object is a function, then we call that function a method of the object. It's just a little bit of a nuance, but in terms of what it does, like I almost said from a functional standpoint, what it really does from a practical standpoint, methods and functions are the same things. So we've actually used a lot of methods already in JavaScript, and we've pretty much taken them for granted, right? Literally everything that we covered in the first day of the arrays lecture, all of those, when I introduced them, I said, hey, these are built into every single array that you ever have, right? JavaScript does it for you, so we don't have to rebuild our own versions of index of, or slice, or includes, even though it's actually not that hard to, right? For some of the workshops, that's what we end up doing. We end up creating our own version of those functions, but JavaScript actually just does it for us. And because JavaScript builds it in so that every single array we ever create already has those functions built in by default, we call those functions methods of our arrays. So here we see a quick example where we're using index of. Okay, so don't be intimidated by the word method. It's just almost a semantic nuance that just means, hey, this function, it's not existing kind of by itself in the wild, not attached to anything. It actually is attached, or actually is quote unquote a part of a specific object. Okay, so that's all we mean. That's all we mean when we say method. If it makes it easier for you to think about it as just a normal function for now, feel free to do that as well. Okay, creating a method or creating a function. So hopefully by now no one's really intimidated by creating functions anymore, right? Because every single workshop we've done basically starts with the words create a function blank that does X. And so creating a function shouldn't be very hard. Now we're just going to combine everything together and say, yesterday when I said the key value pairs, the value of an object can be anything. It can be a string, a number, a boolean, whatever it is. Yeah, I actually admit it can be anything, including a function. So here we see on line 5 through 7 there, essentially, we have another key value pair. The key, remember, has to always be a string. Okay, the key, there's no negotiation there. The key always has to be a string. In this case, the string is called my method. And the value of my method is a function. And we define that function very similar to how we've defined our other functions, right? We have our function keyword, we have our open and close parentheses, and we have our curly braces that kind of designates when the body of our function starts. Okay, and so right now on line 5, all I've done is create a function. Okay, just like how every workshop, all you ever do is create a function. So far in our workshops, we've never had you run your own function just yet, right? Whenever you click run, what happens is our tests, the tests that exist beneath the describe block, those run your functions. All you do is create it and set it up so that other people can use, in this case, our tests can use your functions. Okay, so do not get confused. On line 5 through 7 there, all I am doing is I am creating a function. I am not running a function, right? Because I don't see the function keyword with the curly braces. I don't see an open and close parentheses after it, because only then does it indicate I'm actually invoking a function. Okay, so lines 5 through 7, all I'm doing is creating a function, and on line 11, that's the first place where I actually call the function, because notice how I do gracehopper.myMethod, right? If we go with the logic we learned yesterday in terms of JavaScript kind of going from left to right and handling each action, if you will, one at a time. Line 11, the first gracehopper goes to the gracehopper object. When we do gracehopper.myMethod, it goes to the gracehopper object, gets the value associated with the myMethod key, and then we see the open and close parentheses, which means, hey, let's now invoke this method. Okay, so that's the first time on this page that we are actually calling the myMethod function. Okay, once again, just read it from left to right, make sure that makes sense to you. Grace Hopper object, we're going to the myMethod key and getting the value associated with my method, and then we are invoking it. Okay, and when I do that, I am actually running the function, which is why we see the console log from line 6 being printed. Okay, so here we're actually going to do, we're going to go into a little bit more depth around something called this, but this is just another kind of quick example of the previous slide. So any questions so far with regards to making a function and putting it as the value of an object? Everyone good so far? Okay. So let's keep going. Usually when we call a method, or rather, usually the reason why methods are tied to an object is that it's not really arbitrary. It actually usually has something to do, right? Like that method does something. It interacts with the object that it's attached to. And this is nowhere more true than what we've seen so far with our arrays, right? Like the arrays don't have a function that just console logs out hello world. Or sorry, the arrays don't have a method that console log out hello world, but it does have a method called includes and index of and slice. And all of those methods do something with the object that they're being called on, right? All of those functions do something to the array that it's attached to. Sometimes it might copy it, sometimes it might search it, it might, add or remove elements from it, but all of those do something with the array, which makes sense, right? Because it's like, why will we attach something to an object? Sorry, why would we attach a function to an object if that function doesn't really have anything to do with the object? It doesn't really make too much sense. And so this kind of brings on to, and this is more of a general principle, is that whenever you put a method on an object, usually that means that method should be, we'll say, interacting with the object in some way. Okay, so here if I look at line 7, I put a function under the say quote key, and all it does is console logs out. It's easier to ask for forgiveness than it is to get permission. When I run it on line 13, that's perfectly fine, but it also seems a little bit somewhat I guess not random, but it seems a little bit somewhat kind of strange, right? Now, if that's one of her well-known quotes and we are only attaching it to this Grace Hopper object, then that's totally fine. But usually, as we'll see in the later slides, usually that all of the functions that's attached to an object has some way to interact with the object, or it's very specific to the object. Okay. And by the way, in case people didn't know, the Grace Hopper object we're using here, Grace Hopper is, you might have heard of her from Full Stack Academy's all women coding bootcamp. It's called Grace Hopper Academy. But she's very much a real person. She was in the military, and she's thought of as one of the first computer scientists, I believe. Not just the first female one, but I think one of the first, period. So that's why we're picking her, right? So here in this case for this Grace Hopper object, we have her first name, Grace, last name, Hopper. She was in the military. Her position, her rank was Rear Admiral, and this is a quote, that she may have been known for. Now, if we go a little bit further here, you'll notice on line 9 through 11 here, we have the same object as before, except now we have this function called getAge. Okay, once again, getAge is the key, and the function on lines 9 through 11, that's the value, right? That's the function that we're created. And notice how in this function, before we could just invoke a function and pass nothing in and just kind of console logs what it's supposed to. Here it actually takes in a input, and that input, it looks like we assume it's a number, right? And it's a year, and we return that year minus 1906, which I assume is her birthday. So on line 14 there, if you look at the console log, we call Grace Hopper.getAge. Okay, we're getting the value associated with the getAge key, and we invoke the function, and we're passing in 2018. And so when 2018 minus 1906, that gives us 112. Okay, so once again, this is another example of us creating a method that can take in an input. right? Like if you think about this, it looks a lot like array.push, right? If we have our array, think of the Grace Hopper object as the array, we call that push, and usually we pass something in and it does something. Here, same exact idea. Okay. The reason why I'm kind of being a little bit more verbose about the relationship between a method and its object is because, typically speaking, for the next 2 or 3 slides, we're actually going to build into something called this, and this is more of a conceptual conceptual thing. It's also the only thing harder than trying to understand this is trying to explain this verbally, because you actually don't realize how often you use the word this until you start trying to explain something called this, and then you realize how confusing that is both for yourself and for everyone else who's listening to you. But we're going to kind of start building up to our understand of this. Okay, so on line 7, we give this Grace Hopper object, we give her, or we give it, I guess, a function. It takes in a name, and it console logs out hi, comma, name, I am Rear Admiral Hopper. Okay, so far so good. It makes sense. Except when we think about the second half of that statement, I am Rear Admiral Hopper. You might hear people, as a coding principle, they might say something called, oh, keep your code dry, or DRY. That usually means the DRY stands for don't repeat yourself. And so in programming, almost sometimes to an unhealthy degree, actually, people try to keep their code as dry as possible, which means they hate repeating the same things over and over again. Now, I say unhealthy because the vast majority of instances in which people try to eliminate repetitions, it's great. It's good for the user. It's good for the writer. It makes the code easier and better to understand. Sometimes people will go a little bit overboard, but for now, just kind of keep in mind that when you write code, you don't want to be typing the same things over and over and over again. Usually when you do, it probably means, hey, I should create this thing once, capture it in a variable, and then use that variable everywhere else. Okay, that's just kind of a general thought process you should start building into when you start writing code. So here, if I notice on the second half of my console log here, I am Rear Admiral Hopper. Well, Rear Admiral and Hopper already exist. So even though there's nothing quote unquote wrong with typing it out, it does seem a bit inefficient. So we're going to try to kind of actually optimize that just a tiny bit. Okay. So one of the ways for us to do that, one of the ways for us to get around having to type Rear Admiral Hopper is, if I look now at this function now, what I've done is I've replaced the words Rear Admiral and also the word Hopper with a reference to the object that I am in, right? Notice how on line 10 I say hi, let's say Gabe, I am, and then do Grace Hopper.rank, right? If I look in the Grace Hopper object, well, the Grace Hopper object is the Grace Hopper object is on lines 5 through 12, and I look at the value associated with the rank key. And then for the Grace Hopper.last, I go to the value associated with the last key in the Grace Hopper object. And now when I execute this function, you notice I am still outputting the same thing, right? So if I just look at the output, no one can tell that I've now replaced me typing out Rear Admiral Hopper with using the parameters of the object. But you can actually see now that it's a little bit more efficient, and I'll go back to why it's efficient and why it's more efficient in 1 or 2 slides. But so this is kind of the first step we're taking to kind of get around that. And then here's where kind of we start talking more about the idea of this. Okay. This is a JavaScript concept. It's a reserved word in JavaScript, so it's built in, has very, very special meaning. And in a function, this refers to the object that the function is a method for. Okay, so on line 9 there, when I say this.rank, you can think of it as, oh, if you pretend like you're the function, right? If you pretend like you're the function and you say, what is my this? Well, I'm a method, and my owner, if so to speak, if you say my owner is this Grace Hopper object, therefore Grace Hopper is equal to this. Okay, it's almost like saying like like my parent, right? Like me and someone else can both say my parent, like the words sound the same, but obviously we have different parents, right? And so this takes on very different meaning depending on where it is being used. And that's why it's so tricky sometimes to get your mind around it, is because of the in line 9, I use this and it means Grace Hopper object. I could use this somewhere else and it could mean something very different. So for now, just for our purposes, we're going to simplify it down. We're not going to make it super complex. And generally speaking, when you see this, you can just put yourself in the perspective of the function that is using this and think of, okay, my this is whatever object I am a part of, whatever object I am a method for. Okay, so here on line 9, when I do this dot rank, the function is going to say, okay, I am a method for the Grace Hopper object, therefore this is Grace Hopper, and Grace Hopper dot rank, and then Grace Hopper dot last. Those are the values that I'm going to access when someone says this dot rank and this dot last. And so once again, when I look at my printouts, hi Kate, I am Rear Admiral Hopper. Things make perfect sense. I can't quite, just looking at the console output, I can't quite tell, how we're generating this. But if I look underneath the code, I can say, oh, I am doing this dot rank and this dot last. Any questions so far before we go to the last 2 to 3 slides?
Can you use brackets instead of dot rank, like this bracket?
Yep, absolutely. Dot notation, bracket notation, it doesn't matter. To us, this is just an object, so you can treat it as if it was the object. Yep. Okay then, so actually, this slide. So here we're, I almost said this slide. Okay, on this slide, I guess, I'll walk through this and hopefully gosh, this is so hard. Hopefully this makes quite a bit of sense. On line 12, notice how, okay, sorry, backtrack just a little bit. On line 7 through 9, I created a new function now. The key is get this, and the function, all it does is returns this, okay? This is built into JavaScript. It's predefined at every single instance. In fact, at any single instance, if you console log out this, you will get a value. You will always get a value back. So this exists almost everywhere, right? There's always a context for what quote unquote this is. It's just depending on where you are, it's a little bit, it's different. Okay, so on line 12, I call Grace Hopper.get this, right? Grace Hopper.get this just returns this. And so on line 12, let return object there, that is equal to whatever this is on line 8, okay? And on line 8, what is this? Well, get this is a function. It's a method, and the object that it's a method for is the Grace Hopper object. And so therefore, on line 12, return object is equals to Grace Hopper, which we prove on line 14. And then on line 13, if I do Grace Hopper dot first, it's equal to doing this dot first, which is equal to doing return object dot first, right? So on line 13, return object dot first gives me the value associated with the first key in the Grace Hopper object. And then on line 14, we actually can prove that Grace Hopper is the same thing as return object, which is the same thing as this from line 8. I know the triple equal sign there on line 14 can be slightly confusing given what we talked about yesterday. But in this case, this is like my friends, this is like, what's the example, right? Yeah, like, so yesterday I gave the analogy of if I have a car that's a certain make and model and my friend has the same car with a make and model, even though we both have the same kind of car, they're not the same car, right? Well, in this case, assuming I live with my parents, if I say my family's car is a Prius and my dad says my family's car is a Prius, in those cases, even though we're calling it different things, they both point to we're both talking about the same exact car. And so in this case on line 14 there, we are able to use triple equals. This just says return object is actually the same underlying thing as Grace Hopper. Think of it another way. Return object and Grace Hoppers are two variables that point to the same exact piece of memory in the computer's hardware. that is currently storing the Grasshopper object. Okay, so all of this is just to kind of get you more comfortable with, hey, if you ever need to know what this is, just print it out. You will be able to access it at any given time. And actually, it's pretty helpful when you're first starting out because of kind of how quickly the this could change as you move across different lines in your code.
Is returned object considered I guess a copy?
No, it's not a copy. It is the actual thing. So if it was a copy, line 14 would say false, right? If it was a copy, it would be like my Prius versus my friend's Prius, right? Return object is the same thing as the Grasshopper object. So we're going to cover this a lot more in depth tomorrow when we talk about pass by reference versus pass by value, which is basically all about how you copy different values, how you copy numbers, booleans, and more complex things like arrays and objects. For now, all I'm trying to show you is just this is the actual object. It's like those two are like two names for the same exact thing.
Does that create like some sort of infinite loop where it's like get this is within get this is within get this, you know what I mean?
So usually, so I guess it won't create a loop because
Like
there's,
a loop.
yeah, it's just a,
Kind of keep going infinitely into it.
yeah. I mean, you can do this dot, for example, we can do this dot get this dot get this dot get this if you want. But it doesn't like, actually, no, we can't because this dot get this will return. Oh no, it could because it would, oh, sorry, we would need to execute this. Sorry, so it would be something like I guess you could theoretically, just for the code that we've seen so far, you could do something like this dot get this dot get this, and do this over and over again if you want. So this is totally valid. But that's also no different than doing like Grace Hopper dot get this. Oh, sorry. That's also no difference than doing this, right? Like it's all the same. In this case, this is just, it's almost like another name, right? It's like a nickname. I can think of that thing that way, right? They're pointing to the same exact thing. There's no difference. Okay, cool. So two more slides, and then I'll tie this back to what we did earlier. Okay, so that's the thing of this. So here's an example of an object we call calc. Calc has num1 and num2, a sum function that returns this dot num1 plus this dot num2, and a difference function that returns this dot num1 minus this dot num2. If I do calc sum, all we're doing is adding 20 plus 30, so we get 50. And here's where the value of this really comes in. On line 13, notice how I change num2, right? I change calc.num2. I override whatever the previous value of it was. I now replace that value with 15. And now when I do calc.difference, I'm returning this dot num1 at that point, which is 20. Num1 is still 20. And then minus this dot num2. Well, this dot num2, by the time we hit line 14, that becomes 15. And so when I do calc.difference, I can actually see that, yep, it's 20 minus 15, so I get 5, and then right above it, it's 20 plus 30, the old value of num2, so therefore I get 50. Okay. So so this is like a pretty straightforward example of how we can use this to make our objects a little bit more usable, a little bit more flexible. And the last thing we'll say here is just, like a lot of other things we talk about in this class, there's way more going on than what I've told you with this. It's actually incredibly complex. I don't actually understand a lot of the nuances of it even. So all we're doing here is kind of giving you the quick and dirty primer so that when you see it, you have a good sense of what you're looking at and you know how to approach it, even if we haven't necessarily covered every single nuance. I think on the very first day of class, someone asked about arrow functions and how arrow functions give you a context to this, right? Like this is the this that we were talking about. But there's just a few more complications, a few more nuances there that, quite honestly, you probably won't deal with. Like I said, I don't know all of the complexity of this, but I've never been intimidated. Like it's never caused problems for me. And so what we talked about so far should be enough to kind of definitely get you started, especially for this curriculum and probably even for most of the full-time curriculum as well. So I'm gonna zoom back really quickly and just go back here to let you know why it's super easy for us to use this. If I go back to this example from before, where I manually typing out, hi, Karen, my name, or I am Rear Admiral Hopper, the reason why we like to use this dot first or this dot last instead of typing out the name is because, well, what if my name changes, right? If let's say Grace Hopper, change her first name to, I can't think of anything. We'll go with Gabriella, right? If she changed it, then in my object, I need to go to her first property, right, her first key, and change the value of that to Gabriella. And I also need to go into the greet function and change that to Gabriella as well. And that might not seem very tedious, but imagine if this object had like 40 functions, and all 40 functions made use of her first name in some way. Well, now I actually then need to go in and change her first name in all 40 places, like override the previous version and change it to Gabriella. And then what if she changes her last name, or she changes her rank? What if she gets promoted? Right? Notice how very quickly like it becomes like a very big cascade of changes where one small change needs to be done in multiple places. And really, that's kind of the exact reason why we have variables, right? Is to say, hey, rather than trying to copy and paste this and type this thing out over and over and over again manually, let's just put it all in one place, and everyone else will just reference that one place, right? And so the reason why we're using this to also shorten the code, it's not necessarily just to type less, is that it also makes it a lot more efficient down the road. If we ever need to edit the code, we have one central location where we change it there, and it changes it for everyone else, right? So this is one of the instances in which we actually want to make sure that we're constantly up to date on what the outer level is, as opposed to trying to create our own at every single instance. Okay, so that's pretty much it. So like I said, we didn't talk about too much today in terms of like volume, but the workshop actually will look somewhat similar from yesterday in terms of just, hey, here's an object, here's a functions, let's call it, let's make it do whatever we want it to do. But now we're actually going to make you start using the objects and start kind of building out the relationships between using functions and using that to do something that's inherently related to the object that it's attached to. Okay, any questions? Okay, assuming everyone feels good, then I will get you all started on the workshop.